Hey guys, so today's video is on writing and modeling with equations, and what we're writing and modeling is literally the world around us, the universe around us, and we're just going to do it with numbers, with variables, quantities, etc. So, because math is the language of the universe, you want to try to describe the universe using math. I mean, it only makes sense. You can predict things, you can analyze things, you can do all sorts of stuff, and everything, literally everything has math associated with it. So I'm just going to give an example problem, and I'm not even going to really ask that much at first. We're just going to try to look through it and see what it means. So, for example, you have a $50 budget, $50 for buying snacks for your family, and your family usually likes to eat for snacks chips, popcorn, trail mix, and dried apricots. So, potato chips at the store that you go to, potato chips, I'll just say chips, cost $3 a bag. Popcorn costs $7. Let's see. Trail mix costs $8. And the dried apricots cost $6. So, you have this budget, and you need to buy all of these things. So, first of all, let's just try to figure out really what is given to us in this problem. We know the budget's 50, so whatever this adds up to, like whenever we buy all these things, we can't go over this $50 budget. And we also know we have to get at least one of all of these, because our family really likes them. So, that's good. Now, what we're going to do is identify what we don't know. We don't know how many of each of these things we're going to get yet. And that's what we're going to assign to variables. So we're going to let the number of chips that we're going to get equal the variable c. That's going to represent how many chips we're going to get. Popcorn is going to be p, trail mix is going to be t, and apricots are going to be a. So these are all the variables associated with how many of each of these things we're going to buy at the store. And because we know what each of these things costs, we know, let's say, like, if we got 2 bags of chips, well, that would be 3 times 2, which means it would cost $6 total. So, the way we can represent this is that the amount that all the chips are going to cost is the amount that one bag of chips cost times how many bags we buy. So, basically, what this is going to look like is we're going to buy some amount of chips times 3, because that's how much it costs, plus, because we know we have to get all the rest of them, 7p plus 8t plus 6a. And this is gonna be literally everything that we're buying. And the other thing that we know is that this cannot go over $50, meaning that this has to be less than or equal to $50, because that is our budget. Okay, and that is literally all that we're gonna kind of do right now. So, obviously we know that all these variables, all these numbers have to be at least 1, but we can play with it. You know, we can ask our family, are we feeling more chips this week or popcorn? We can assign if the family is like, you know, actually we don't want chips this week. We know that this is going to be 0, so we can just kind of cancel that out and say, okay, well, now we have more money to buy all the rest of the stuff. But now that we have this model for our predicament, we can do a bunch of stuff with it. So, and that's really basically it. You just using the vocabulary terms you need to know. These numbers right here are their constraints. This bag of chips costs $3. We can't do anything about that. We can't change that. We have to go less than or equal to $50 for the budget. We can't change that either. The only things that we can change are the variables, and that is these right here, the letters. And yeah, also, side note, because this is also in your lesson, kind of randomly, but they did some like cool percentage tricks, like you have to be able to do that in your head. A cool percentage trick that I use all the time is that 8% of 25 is the exact same thing as 25% of 8, and one of those is a lot easier to do in your head than the other. So, Continuing with this video, I'm just going to give another example. So, some dude has to travel 1,000 miles to get to his nearest family member. He already has traveled 350 miles in that direction, right? So his home is here, family is 1,000 miles away, he's already 350 in that direction. And he's traveling at 13 miles per hour. How long will it take for him to get there? So again, whenever you're given a word problem, at first they can appear really scary, because it's like, okay, it's not just numbers this time, now I actually have to read English, and English sucks. But what we do know are the numbers, and we can write those down. So get rid of all the rest of the words, now we just have the numbers. What we do know is that or we can draw a picture. Actually, let's do that, because that's really helpful sometimes. Here's his home, H for home. Then 1,000 miles away, here's his family member. And this is 1,000 miles. And he has already traveled in this direction towards his family member 350 miles. The other thing that we know is that he is traveling at a constant speed of 13 miles per hour. Okay. And what we're being asked is how long, which means this is going to be a time unit, so probably hours, right? Miles per hour will it take for him to get there. Okay, what we need to know in order to solve how long it'll take for him to get there is the distance he has left and how fast he's traveling. And we already know how fast he's traveling. So all we need to do is get the distance that he has left. In this case, if this is 1,000, the total thing, and he's already traveled 350, then this rest of it is going to be 650 miles. Okay, now let's think about it. Let's say we're not exactly sure how to connect these two. How do we get from miles per hour to miles? Well, it's really, really, really helpful to actually look at the variable name. This is 13 miles per hour. This literally means this is 13 miles per hour. It's a ratio, is what that means. So he travels 13 miles per every 1 hour, right? That's a ratio. And then that is going to be equal to 650, because that's miles, right? And what we're looking for is how many hours it's going to take for him to get there. And we got that from just looking at the variables, right? If he's traveling 13 miles in 1 hour, and he needs to travel 650 miles, then how many hours is he going to do? So we're relating those two things. Okay, now it's a very simple fraction kind of solving, right? We can cross multiply, we can do 13x is equal to 650, and we get x is equal to 5. But what's the unit for that? Ah, yes, hours. So it's going to take him 5 hours to travel 650 miles. 50? Excuse me. It'll take him... Oh wow, I was really hoping for this guy. My mistake. It'll take him 50 hours to get to travel 650 miles, which is atrocious. He's got to be, I don't know, running, riding a bike, riding a unicycle. I'm not exactly sure what this kid's doing, but yeah, that's going to take him 50 hours. And again, we got that from evaluating what we do have and trying to figure out what we don't have, and then using what we do have to get what we don't have. And that is literally all of math, basically. So yeah, hope that helped.